Gemini 3.6 just dropped, and I've been running it hard since day one. It's faster, it's cheaper, it uses 17% fewer output tokens, and Google says tasks complete 12% quicker on average. Community reports are already showing a price cut to match. But the real story is way more complicated than the headline. And here's the crazy part. This model is free to try right now on GeminiGoogle.com, and the efficiency gains are real and measurable. But some of the other claims Google is making, developers are already punching holes in them, and the vision regression alone is enough to break production pipelines. So in the next few minutes, you're going to know exactly where Gemini 3.6 actually delivers, where it quietly steps backward from the previous version, and which tasks you should never route through it. Because if you're building on this model right now without knowing this, you're going to run into problems you didn't see coming. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. I go through every claim, I try the thing myself, and I tell you what's actually worth your time. And if you're new here, I read every comment. So drop your thoughts below and tell me, are you already on Gemini 3.6, or are you still running 3.5 Flash? So here's what's happening right now. Gemini 3.5 Flash is genuinely good, and I mean that. It's fast, it handles high-volume tasks well, the vision output is precise, and the conversational quality is solid enough that developers built real workflows on top of it, and it earned that trust. It's not a toy. But there's a massive problem. Google controls the model, the pricing, and when it gets swapped out, so you don't get to stay on 3.5 Flash forever, if Google decides 3.6 is the default. Your pipeline moves when they say it moves, and if 3.6 regresses on the exact capabilities you built around, you find out the hard way. Alright, so let's talk about efficiency first, because this is where Gemini 3.6 actually makes a real case for itself. The core promise is simple. Fewer tokens out, faster completions, lower cost per call. And if you're running thousands of API calls a day, even a 17% token reduction compounds into real money saved every month, which is not a small thing at scale. Okay, so when I tried it, the efficiency story touches a lot of things. Output token count, task completion speed, API pricing, high volume batch jobs, simple summarization pipelines, classification tasks, the list goes on. Google claims 17% fewer output tokens versus 3.5 Flash, and 12% faster task completion on average, and community reports are already aligning on a similar price cut. So the on-screen number right there is 17% less, 12% faster. Now, I want to be straight with you here. The 17% token reduction and the 12% speed improvement are vendor claims from Google. They're not independently verified, so I'd take them with a grain of salt, but community developers are reporting pricing cuts that line up with the token reduction, which is at least consistent, and what that means in practice is if your use case is high volume and simple. The cost savings are probably real, but if you need precision, that's a different conversation. Okay, so now we get into the part that actually surprised me, and not in a good way. Google positioned 3.6 Flash as having improved multimodal performance, which sounds great if you're building anything that needs to look at images and identify what's in them. Automated quality checks, inventory systems, anything pulling structured data out of visual input. And the stake here is real. If the vision regresses, pipelines break. So here's what the community found. Detection accuracy. Gemini 3.6 Flash falls to the bottom half of the pack on map 50, well behind 3.5 Flash and even behind the cheaper flashlight. Bounding box precision. Instead of several tight, precise boxes, the model often returns one large, loose box. JSON output reliability. The model writes malformed JSON often enough that some responses fail to parse entirely, and that last one is a production killer. To be fair, this is community-reported data from RoboFlow's developer testing, not Google's own numbers. So I want to be honest about that. But the fact that it's worse than the cheaper flashlight model on object detection is a pretty damning signal. And if you're running any automated workflow that depends on structured vision output, you need to try this on your own data before you migrate, because newer doesn't mean safer. Hey, real quick, if what you've heard so far is already useful, hit subscribe, because I'm going deep on every major model drop this year, and the next one builds directly on what we're covering right now. And you don't want to be 2 videos behind when this stuff moves this fast. Alright, so the third thing I looked at is front-end generation and spatial reasoning, which matters a lot if you're using the model to generate UI components or anything that requires understanding where things are in space, like frame-by-frame video analysis or 3D layout work. And Google's coding benchmarks look strong on paper, but benchmarks don't always tell you what happens when you actually try to build something. So I tried spinning up a small UI with Gemini 3.6 Flash, nothing fancy, a 2-shot component generation task, and the output came back with messy, nested components and broken interaction logic. Not subtle issues, stuff that would cost you real debugging time, and community developer testing from 4SAPI backs this up. Spatial reasoning is also down compared to 3.5 Flash, and 3D visualization results are described as, quote, terrible. Now, to be clear, this is community reported, not from Google's own benchmarks, and my own experience was limited, but the pattern is consistent across multiple developers. So if you're doing front-end work or anything spatially complex, 3.5 Flash is honestly still the safer call right now because the speed gains don't make up for broken component logic. You have to manually fix every time. Okay, last one, and this is the hardest to quantify, but maybe the most important for day-to-day use. Reasoning quality and conversational nuance, which is really about whether the model actually pushes back when you're wrong, whether it catches its own grammar, and whether it gives you a real answer or just tells you what you want to hear. So when I tried it in conversational workflows, it felt a little too agreeable, and community reports are calling this out directly. Grammatical errors showing up in outputs, the model being overly sycophantic, agreeing with user premises instead of pushing back with evidence. And here's why that matters practically. If you're using this model to sanity check your own thinking, and it just agrees with everything, it's not actually helping you. I want to be upfront. None of this is from Google's published data. It's entirely community reported, and I couldn't find any official benchmark that measures sycophancy or conversational nuance, so apply appropriate skepticism. But the consistency of the feedback across early adopters is hard to ignore, and if your use case depends on the model disagreeing with you intelligently, this is worth watching closely. So here's where Gemini 3.6 Flash actually makes sense. If you're running high-volume, simple tasks and paying the old price per token, you're now paying 17% less, you're finishing 12% faster, and you're not burning budget on batch jobs that don't need deep reasoning. So for classification, summarization, and high-frequency simple calls, Gemini 3.6 Flash is the right tool. But for object detection, front-end generation, spatial reasoning, or any workflow where you need the model to push back on you with nuance, Gemini 3.6 Flash falls short right now. The regressions are real, and I'd stick with 3.5 Flash for those tasks until this gets addressed. And just so you know, nobody's paying me for this. I have no relationship with Google, I'm just telling you what I found. So here's what you should do. First, go to GeminiGoogle.com right now and try Gemini 3.6 Flash on a task you actually run, not a demo prompt, your real workflow. Second, if you're using it for vision or object detection, run it against the same image set you use with 3.5 Flash and compare the bounding box output side by side before you commit to anything. Third, if your pipeline depends on structured JSON output from vision tasks, add a parsing validation step before you migrate, because malformed JSON from 3.6 Flash is a known issue, and it will silently break things. Fourth, for any high-volume, simple task like classification or summarization, swap in 3.6 Flash and watch your token usage for a week, because the 17% reduction should show up in your billing pretty clearly. Within 2 years, I think the efficiency gap between Flash models is going to get wide enough that the cost savings alone justify building around them for simple tasks, and the people who figure out right now which tasks to route to cheap and fast versus deep and precise are going to have a real edge, because Gemini 3.6 Flash delivers on that one core promise. 17% fewer tokens, 12% faster, and that's real, so build around it smartly. And the best part, this was useful, hit like and subscribe, because the next video is going deep on how to actually structure your API routing, so you're using the right model for the right task and not overpaying on every call. And that one is going to save you real money if you're building at scale. So, I'll see you there.